So, in the summer of 2023, I've attended a summer program called SHAD Canada in Ontario Tech University, and we were given a month-long design project, and the topic name is Community Perspectives of Living Spaces. How might we reimagine living spaces for Canadians in ways that increase sustainability, affordability, accessibility, and community connection? This project was very new to me. It was nothing that I've ever done before, and our team and I, we developed a sustainable homeless shelter, I think, and after SHAD, the thought of sustainable home design lingered, and so after SHAD, after 2023, the entirety of grade 11 and 12, I have read hundreds of books, watched hundreds of videos, and really developed a strong passion towards building sustainable technology in Canada and worldwide, honestly. The most notable names that come to mind is Andrew Millison from the YouTube channel and Acorn Land Labs, run by Kimball Hildreth. Those two guys are incredible, as well as hundreds of other YouTubers' videos I watched, and I gained a lot of information. And so, after that, I've joined where I am right now, the University of Ottawa for Mechanical Engineering, and we have a course called Introduction to Engineering Design. And guess what? Our design project for the entire semester is how we retrofit sustainable modular housing. Okay, so everything that I learned about all my experiences, it all boils down to this course where I get to apply everything that I've learned. And so, okay, sustainable modular housing. And yeah, that's the introduction. I want to show you some of the work that I've done. As you can see right here, this is a brainstorming phase of our project, and there are several ideas that I've come up with. So let me take you through this. So, all humans, as we know, needs food, water, shelter, energy, and sanitation. And they also need transportation to get around, but that's not something that we need at the moment. From Acorn Land Labs, Kimball Hildreth, and many people, we think that water, energy, sanitation, and food must be produced locally and sustainability and affordability, obviously. A shelter should be able to produce a part, not fully, but a part of its food, water, and manage its energy and sanitation needs. We have 4 people in our group currently in engineering design, and we have picked a couple. Transportation is a completely other thing that we cannot, it's off our, right? Food is also off. And so that leaves with water, energy, shelter, and transportation. I myself have taken water and sanitation, Another person has taken shelter, and another has taken energy. HVAC. So in terms of water, I'm taking freshwater systems and wastewater systems, which comes under water and sanitation. My other team member took structure, STRUC, that's not right, and the other took HVAC, and the other took electricity. Right, so in terms of fresh water, I want my house to reduce utility bills, reduce the water that the house takes from the city. And so I want the house to produce its own fresh water from rainwater. And I want the house to recycle the used water from showers, sinks, laundry, and recycle it. My other friend, who's taken structure, is looking at manufacturing. How might you, so these are modular houses, right? So we are taking prefabricated panels that are built in factories, and we're assembling them on site. That reduces the amount of time needed to build a house from maybe 3 years to just 5 months. So obviously building the panels and building everything in the factory takes time, but it's inside an enclosed factory, so there is no weather delays, or you don't need skilled workers that you need to hire all the time. Everything is done in the factory. And so those factory components are manufactured and then brought over to the site where it's just assembled, and a house can be built in about 5 months maybe. So that's the manufacturing, right? The HVAC and electricity. I'm not sure too much about HVAC, but it's mostly passive design, meaning the sunlight heats the house in the winter and stores it in thermal mass and releases it at night, meaning it's a self-heated house. And in terms of electricity, my friend is doing solar. I want to talk about rainwater harvesting and wastewater recycling specifically. So in my list of ideas, I've come up with, I plan on integrating a compact rainwater harvesting system and a gray water recycling system inside the house, specifically in the crawl space and the dead space, to promote water sustainability, high efficiency, affordability. This design excludes a local black water sewage treatment system to keep the setup simple, cost-effective, and maintenance-free. Okay, so obviously when you use water from the bathroom, when you flush the toilet, it produces sewage, black water. And so this black water is very polluted. It's requires lots of energy and lots of space to treat it. And in order to build sustainable, affordable houses for Canadians, treating black water is just not viable. So in our project, we're thinking of just sending it down the drain to the municipality. But gray water, on the other hand, is just slightly dirty water. When you take a shower for 10 minutes, all that you do is just send hot water down the drain, and when you wash your hands, you're just sending slightly soapy water down the drain. This accounts for, I think, half the wastewater produced in the house, gray water, and the other half is flushing toilet, and the other half, small bit, is drinking water, cooking, right? here is, so these are different systems that human needs. These are subsystems, and this is a subsystem of the rainwater and the wastewater filtration system. Let me quickly show you. Here, rainwater is harvested from the roof. It's stored, filtered, and pumped to all the freshwater appliances. And then it gets diverted into a gray water recycling system, which cleans the gray water, and then pumps it into gray water appliances. And then once the water is recycled several times, it's sent down the sewer line. This subsystem can be split into different stages. This is where the roof catches the water and leaves are filtered, and then like bird poop and very dirty water coming from the roof for the first 5 minutes of the rain is flushed, and so on. Yep. Here is all my ideas that I've come up with after 6 hours of brainstorming. And this not only contains ideas for a gray water recycling system, but also the heating system. Maybe in the factory, you could 3D print your houses, 3D print your panels, which can save lots of time and cost money. Here is a freshwater rainwater filtering system using silver. And yeah. Coming down to my laptop, I have connected all my ideas from this paper, my brainstorming board, and I've put it into this document and organized all my ideas. Here is just a document showing how energy intensive different water filters can be, and combinations of gray water recycling, gravity purification, and pump filtering, and the amount of water it can output. So it's a graph showing the different combinations of pumps, how much water can output, how much energy it's going to take, and this will determine how much money you'll save. All the way here is the most expensive water, and all the way down here is the cheapest water. As you can see there, it says higher upfront cost, but when you live in a house for 20, 30 years, this system will lower your utility bills. Let's say you pay $100 for water and sewage management. Over here, you'll only need to pay, let's say, $5 a month. And here you'll have to pay $100 per month. So most expensive to least expensive. Yeah. So that was a long 12-minute video. I'm really passionate about this topic, and I want to share it to as many people as possible on Instagram, LinkedIn, YouTube. And yeah, this is the project that I'm working on. I'd love to talk to as many people about it as possible, to my professors, anybody on LinkedIn. Just approach me, and I'd love to talk about it. And I'm hoping that I could get maybe a summer job, internship, or anything related to sustainable modular housing, or sustainable technology, anything related. Thank you very much for watching.